Today I am going to discuss structure of fructose. Now fructose and glucose, they both have same molecular formula C6H12O6, but the structural formula are different. In glucose and fructose the structures are different. You can see this structure, middle structure, is the linear structure of glucose. In that, this one is our aldehyde group. Okay. Now, in the structure of fructose, total number of carbon you can calculate 1, 2, 3, 4, 5, 6. That are same. Structure here the functional group is different. C double bond O, then carbon, and here also carbon, means it is ketone group. Again, the functional group in glucose is aldehyde group, but functional group in fructose is ketone group. That is the main difference between fructose and glucose. Both have same molecular formula, as I told you, C6H12O6. Now, fructose has configuration D minus. Now what is D and what is minus sign? That we have discussed in previous session. So I am not going to discuss that again here. These both are the cyclic form of fructose. You can see here on carbon number 1, the position of CH2OH and OH, they both are different. Position of CH2OH and OH, it is different in this both structure. Rest of it is same. CH2OH, H and OH, OH and H, they are same. Also you can notice here, if I number the carbons, there is ether linkage on carbon number 2 and carbon number 5. In glucose, the ether linkage was on carbon number 1 and carbon number 5. Here, the ether linkage is between carbon number 2 and 5. That is also a difference between fructose and glucose. If CH2OH group is on left hand side, it is called D minus fructose, alpha D minus fructose. If CH2OH is on right hand side, it is called beta D minus fructose. These both are cyclic structures of fructose. This one is linear structure. Both are cyclic structures. So fructose also has 3 structures, linear one and 2 cyclic structures. Now, next point is disaccharides. Now, what is disaccharide? So, on hydrolysis, disaccharides yields 2 molecules of same or different monosaccharides. Monosaccharides are fructose, glucose, etc. When we perform hydrolysis reaction on disaccharide, it gives us 2 same, means 2 glucose it can give, or 2 fructose molecule, or different, means we can take 1 glucose and 1 fructose, like that. So it can give 2 molecules of same or different monosaccharides. Both monosaccharide in the structure of disaccharide, they both are connected with glycosidic linkage. What is glycosidic linkage? You can see here, this one is sucrose, C12H22O11. When we perform hydrolysis reaction, H2O and H+, it gives us glucose and fructose, C6H12O6, C6H12O6. It gives us glucose and fructose. Now this is the structure of disaccharide, means sucrose. You can see, this one is our glucose structure, this one is our fructose structure. In fructose, you can check here, total 5-member ring is there. In fructose, 6-member ring is there. Okay, now these both glucose and fructose are connected with this ether linkage, and this ether linkage, it is called glycosidic linkage. Okay. Connection between glucose and fructose, or connection between two monosaccharides, that is called glycosidic linkage. And in glycosidic linkage there is oxygen between two structures. Okay. Now here the main molecule means sucrose. This is our parent molecule. This was our disaccharide. This disaccharide is dextrorotatory, means it shifts plane polarized light in right hand side. When we perform hydrolysis reaction, as we saw, it gives glucose and fructose. Now in that, glucose is dextrorotatory and fructose is levorotatory. Okay. Again, sucrose, main parent molecule, that is dextrorotatory. Now we are performing hydrolysis reaction on it. On hydrolysis, two molecules we will get, glucose and fructose. From that, glucose is dextrorotatory and fructose is levorotatory. On completion of reaction, we will get a mixture of glucose and fructose. Now glucose, that shifts plane polarized light into right hand side up to this degree, 52.5 degree. And fructose, that shifts plane polarized light negative 92.4 degree. Here the rotation of fructose is more, so after hydrolysis as product we will get the mixture of glucose and fructose, and that mixture is also levorotatory. You can see sucrose was dextrorotatory. After performing the reaction of hydrolysis, we will get mixture of glucose and fructose, and that mixture is levorotatory. Now change in rotation is there, so this is called invert sugar. Okay, this change in rotation, it is called invert sugar.